Dear children, welcome to this session on Chapter 10, Python, Classes and Objects. Java, C++, Go, Ruby, and Python are listed as the top programming languages that follow the concepts of object-oriented programming. Object-oriented programming is built on the principles of encapsulation, polymorphism, and inheritance. Python is an object-oriented programming language, which means Python follows the principles of encapsulation, polymorphism, and inheritance. What is an object in object-oriented programming? An object is a data structure that encapsulates data and functions into a single entity. C++ is an object-oriented programming language. But do you know that C language is based on procedural programming methodology? What is meant by procedural programming? In this, the data and functions exist as individual entities. Data and functions are separate entities. But look at the definition of an object in object-oriented programming. An object is a data structure that encapsulates data and functions into a single entity. Encapsulate means to enclose in or to bind together. So in object-oriented programming, the data and its associated functions are bound together into a single entity or single unit called object. The process of binding together data and functions into an object is called encapsulation. The term encapsulation is derived from the word encapsulate. Encapsulate means to enclose in, as of in a capsule. Let me explain the term object with an illustration. Here I have three objects, B1, B2, B3. Actually, they are three boxes. Each of these objects have its own length, its own value for breadth, and its own value for height. Also, the volumes of each of these objects are calculated as follows. Do you think that these objects are different? No, they are not. Actually, they are similar because all the three objects have properties or attributes as length, breadth, and height. And the volume is calculated by the formula length into breadth into height. Now, by applying encapsulation, I am going to create another object which is going to be common to all these objects B1, B2, B3. So here I have a common object called box, which has the same properties of B1, B2, B3. That is length, breadth, and height. and volume is calculated by length into breadth into height. Now this object box, which is common to all the other objects B1, B2, B3, is called as a template. A template is a model for an object. Now we can say that from this template box only we are creating objects B1, B2, B3. In object-oriented programming, template is called as class. And from this class box, objects are created. Therefore, class is a template for the object. From this illustration, it must be clear to you that objects are created from the class, which means you have to define a class and then from the class you have to create the objects. So we can conclude that classes and objects are the key features in object-oriented programming. In Python, every variable you create in the program is an object of some class. Here I have taken 3 variables A, B, C with certain values. When I print the type of each of these variables, the type of A is class int, which means A is an object of class int. Type of B is class string. The variable B is an object of class string. Type of C is class float. The variable C is an object of the class float. Similarly, type of L gives class list. List object L is an object of class list. Type of T is class tuple. The object T is created from the class tuple. Type of S is class set. The variable S is an object of class set. From all this, it is clear to us that class is the main building block in Python. Whatever you create in Python is an object of a certain class. That is why class is the main building block in Python. What you see here are some of the data types in Python: int, string, float, bool, complex list, tuple, set, dictionary. But in our example, I have taken a class called box. Is there a class box in Python? No, it is not available. But Python allows us to create our own data types, which means you can create your own class. When you create your own class, it is called as user-defined data type. So when you are creating a class, means when you are creating a new class, you are creating a new data type. That is a user-defined data type. So here box is a user-defined data type. Next I am going to show you the syntax for creating a box. So we are saying that we can create our own data type or own classes in Python. But how to do it? For that you have to follow a syntax. Class name colon. Here class is the keyword followed by class name, and after the class name you have to place a colon, and then within the body of the class you can have several statements. These statements must be properly indented. The statements in the body of the class can be variable declarations, control structures, or function definitions. Keeping this syntax, let me now create my own class called box. Class box colon. Class is the keyword to be used. Space. Box is the class name. After the class name, you place a colon. And within the body of the class, I am creating 3 variables, length, breadth, and height, with values 10, 7, and 5. These variables are within the class, so they are called as class variables. Now I have defined my own class called box. It is time for me to create objects from this class. To create an object, I will write an assignment statement in the outer indent level as follows. B1 is equal to box parenthesis. Here B1 is my object, is equal to box is the class name which I have already defined, and the class name should be followed by a pair of parentheses. In object-oriented programming, object is an instance of a class. And in this assignment statement, B1 is equal to box parenthesis. An instance of the class box is created. That is, an object of the class box is created. Instantiation takes place. The term instantiation is derived from the word instance, which means creating an object. The process of creating an object of the class is called instantiation. Having created my object B1, next I want to access the class variables outside the class. For that I write a print statement, print b1.length, b1.breadth, b1.height. Class variables are also called class members because they are members of the class. And to access the member length, you cannot directly write as length. You have to write as b1.length. That is object dot class member. Therefore, the syntax to be followed to access a class member is object dot class member. I want to create some space over here. So let me write the 3 assignment statements. Length is equal to 10, breadth is equal to 7, and height is equal to 5 into one statement. So I have more space here. Recall that these 3 are called as class variables. Next, I want to find the volume for my object. For that, I have to define a function within the class box to calculate the volume. Def box underscore wall self colon. How to define a function has been already taught to you in chapter 7. So here the keyword def is to be used to define a function, followed by the function name, which is box underscore wall. And as you have noticed, every function within the class must have the first argument as self. It is compulsory to have self as the first argument for every function you define within your class. So within the body of this function, I calculate volume as volume is equal to box.length into box.breadth into box.height. And then I print volume. Observe carefully. Here I am using length as box.length. So class variables which are accessed within another function must be referred with class name box.length, box.breadth, box.height. So this function definition in Python is called as a method. That is, any function you define within a class is not to be called as a function, but it should be called as a method. So a class can contain class variables and methods. Class variables and methods are together called as members of a class. Class members. A class consists of class variables and methods. Class variables and methods are together called as class members. Now coming back to our example, we already saw how to access class members. Following the same syntax, now let me access the method box underscore wall outside the class. For that, I write this statement b1 dot box underscore wall parenthesis. By using this syntax object dot class member. So b1 is my object dot box wall. It's my class member, which is my method. So object dot method. You can say like that also. So this function call b1.boxWall will invoke the method within the class, this method, calculate the volume and then print volume. Recall that I have used the same syntax when I accessed a class variable object.classMember. My object B1 has the values 10, 7, 5 for length, breadth and height attributes. If I create another object B2 by the statement B2 is equal to box and parenthesis, the object B2 will also have 10, 7, 5 as the values for its length, breadth and height. How many ever objects I create, all the objects will take the same values 10, 7, 5 for its attributes length, breadth and height. But this was not my intention. I wanted to create objects with each object having its own values for length, breadth and height. So now I have to redefine my class box so that I am able to create objects with each object having unique values for its attributes length, breadth and height. For that, I have to teach you about constructor and destructor. So in my class box, I am going to define a method with the name init. Follow carefully. Def space underscore underscore init underscore underscore self comma L comma B comma H colon, and within the body of this method, self dot length is equal to L, self dot breadth is equal to B, self dot height is equal to H. That is, the values in these parameters L, B, H are now assigned to self dot length, self dot breadth and self dot height. The variables length, breadth and height over here, they are called class variables, and the variables defined within the init method are called as instance variables. Since I have created instance variables for length, breadth and height, I am going to remove the class variables from here. Now, the method which I have created is called as a constructor. Below the constructor, I will place the method which will find the volume of the box. Look at the statement here. Volume is equal to box dot length into box dot breadth into box dot height. Box dot length. This syntax be used when length, breadth and height were class variables. But now length, breadth and height are instance variables. So I have to remove this statement and replace it with this one. That is, volume is equal to self dot length into self dot breadth into self dot height. Now my class is complete with a constructor and a method. I am ready to create an object. B1 is equal to box 10, 7, 5. Here B1 is the object, and as I have told you already, this statement in which the object is created is called instantiation. During instantiation, constructor gets executed automatically when an object is created. So whenever you create an object, the constructor gets executed automatically. That is the nature of constructor. During this process, the values 10, 7, 5 are passed to the parameters L, B, H in the constructor. 10 is passed to L, 7 is passed to B, and 5 is passed to H. Note that nothing is passed to the first parameter self. Object B1 is created by the constructor with values 10, 7 and 5 for length, breadth and height attributes. Constructor is a special method that creates and initializes an object. Why is constructor a special method? Because it has a definite name, underscore underscore init underscore underscore. Constructor is executed automatically when the object is created. And constructor is the one which initializes the object. So constructor is executed automatically when the object is created, and constructor is the one which initializes the object. That is why constructor is a special method within the class. Next, I will invoke the method box_wall in order to calculate the volume of the object B1. B1 dot box_wall parenthesis. B1 is the object dot box_wall is the method or member. So this syntax has been followed here. Object dot class member. You get the output as 350 because during function call of box_wall, this method is executed where the volume is calculated. Volume is equal to self.length into self.breadth into self.height. That is 10 into 7 into 5. That will be the value of volume, and print volume gives the output as 350. Now, if I create another object B2, B2 is equal to box 6, 3, 8. Now, as you know already, as soon as you create an object, constructor gets executed. During that process, the values given over here, 6, 3, 8, are passed to the parameters L, B, H. And these values 6, 3, 8 will be stored in self.length, self.breadth and self.height. Look at the object B2. It has length 6, breadth 3 and height 8. And next, when I give the statement B2.box_wall, the method box_wall is invoked for the object B2, and volume is calculated as self.length into self.breadth into self.height, which will be 6 into 3 into 8. Print volume will give the output as 144. So, by using constructor, I am now able to create different objects, and each object having its own values for length, breadth and height. Next, I will tell about another special method with the name del. Def space underscore underscore del underscore underscore self colon. And within this method, I will write a print statement, print destructor of class box. From the message itself, it is clear to us that this method with the name underscore underscore del underscore underscore is called as destructor. Destructor is a special method that gets executed automatically when an object goes out of class scope. In other words, destructor is a special method that executes automatically when the execution of the program comes to an end. The work of the destructor is to release the memory of unused objects. But the programmer need not write a destructor in every class because Python has a technique called automatic garbage collection, by which Python itself will free the memory blocks of unused objects. Now we will see the differences between constructor and destructor. In Python, the method __init__ is called constructor, and the method __del__ is called destructor. Constructor is executed automatically when an object is created. Destructor is executed automatically when an object goes out of class scope. Constructor is executed automatically when an object is created. I can also write this as constructor is executed automatically when an object comes into class scope. So for destructor, it is when an object goes out of class scope. Next, I will teach you about public and private class members. Here I have a class sample, and within the body of this class, I will write a constructor, and inside this constructor, I will take two instance variables, n1 and n2. n1 does not have any prefix. It is a public data member, whereas the variable n2 is prefixed with double underscore. It is a private member. Let me create an object for this class sample. S1 is equal to sample 10, 20. And now I am going to access this public member n1 in a print statement. Print s1.n1, and in the next print statement I will access the private member s1.__n2. So object.member, using this syntax. The first print gives the output as 10 because the value of n1 is 10. And the second print statement throws an error. This is because n2 is a private member. So how do we identify a private member? By the double underscore. A private member cannot be accessed outside the class. If you access, Python will throw error. So the difference between public member and private member is public member is accessible outside the class and a private member is not accessible outside the class. I will now review all the important facts that I taught you in this session. Python is an object-oriented programming language. Classes and objects are the key features in object-oriented programming. Class is a template for the object, and class is the main building block in Python. That's all in this session. Thank you.